This is Math 9 class with Ma'am MC, Ma'am Ford, and Sir Reynold. Today, I will be discussing laws and radicals. So the objective of this discussion is for you learners to derive the laws of radicals. For any real number a and b, and any integer n greater than 1, if a raised to n is equal to b, then a is an nth root of b. In symbols, we write that as a is equal to nth root of b if and only if a raised to n is equal to b. Now, if the index is even, such as 2, 4, 6, and so on, the radicand must be non-negative for the root to be a real number. Now, take a look at this one. We have here nth root of b. Our index here is n, and our b here is the radicand. Now, if your n here is even number, then your b must not be a negative number. It should be a non-negative. So it can be 0 or it can be positive in order for us to have a root which is a real number. Now, what would happen if the index is even and the radicand is negative? Say, for example, you have square root of negative 9. In square root of negative 9, 2 is the index. Negative 9 is the radicand. Now, if we are going to get the square root of negative 9, that will be thinking of a certain number na kung i-multiply mo sa self na, ang answer is negative 9. Now, is there such number na kung i-multiply mo sa self na, ang answer is negative 9? Now, let us try positive 3. Positive 3 squared, or positive 3 times 3 is equal to positive 9. How about negative 3? Negative 3 times negative 3 is still positive 9. So there's no chance that when you multiply a certain number to itself, the answer is a negative number. Or if you square a certain number, the answer is a negative number. It will always be a positive number. So it is not possible to get the square root of a negative number. So it is very important to take note that if the index is even, your radicand must be a non-negative number in order for us to have a real number. Because if your index is even and your radicand is negative or negative number, then you will have an imaginary root. Okay? Now, how about if the index is odd? If the index is odd, the radicand may be any real number. So, if your index is odd, you can have a positive number, a negative number, or a 0 as your radicand. You will always have a real number as the root. Okay? Now, let us discuss the laws on radicals. Now, let us assume that when n is even and a is greater than 0. What does it mean if we say a is greater than 0? What are those numbers greater than 0? Okay, we mean the positive numbers. If your a is positive number, so we assume here that your a is a positive number. Now, we will have the first law on radicals. The first law on radicals states that nth root of a quantity raised to n is equal to a. So, what does it mean? So it means that when the radical is raised to the exponent equal to its index, the value is equal to its radicand. Now let's go back to this one. Nth root of a quantity raised to n. Your n here is your index. A is the radicand, and the n outside your parenthesis is called the exponent. Now notice that the index and the exponent here are just the same. They are equal. Now if that happens, then the answer to this expression is equal to the radicand. So ang radicand lang, wala nang imo nga radical symbol, wala nang imo nga exponent. That is if, again, the index is equal to the exponent. Let's have some examples. Cube root of 4 quantity raised to 3 is equal to 4. So notice here that 4 is the radicand. Our index here is 3 and our exponent here is 3. So the index is the same as the exponent. So according to the first law on radicals, it states that if the index and exponent are the same, then our final answer here, if we are going to simplify this one, is only the radicand. Okay, so which is 4. Now let us have this one. Square root of 64. So notice that there is no exponent here. We only have our square root and then our 64 to be the radicand. So our index here is 2 and our exponent will be 1. So kung wala siyang exponent, it's understandable that it's 1. Now, we can express 64 into an expression with an exponent which is equal to our radicand. We can express 64 as 8 squared because 8 squared is just equal to 64 and 64 is equal to a squared. Now, we have here square root of 8 squared. Again, we have converted, or we have changed our 64. We have expressed 64 in such a way that it will have a base and an exponent. Now, our exponent here is 2. So 2 is the exponent. Our index here is 2. So again, the index is the same as the exponent. So our final answer here is the radicand. So our final answer for this expression is positive 8. So again, this is the first law on radicals. So it states that if the index and the exponent are the same, then the final answer, if you simplify this expression, will be the radicand. Okay? So we assume again that your n is even and a is greater than 0. We will proceed with the second law on radicals. So the second law on radicals states that nth root of a divided by b is equal to nth root of a divided by nth root of b, where your b must be greater than 0. That means to say your b must be positive. It cannot be equal to 0, because if that will happen, we will have an undefined solution or undefined answer, because your denominator is equal to 0, and we cannot have negative number because we have assumed here that your n is even. Again, if your n is even, your radicand must be positive. Now, this law on radical states that if we divide your numerator by your denominator before getting the nth root, that would be equal to the expression wherein we get first the individual nth root of your numerator and denominator before we divide them. So again, in a radical where the radicand is in a fraction form, it can be expressed as a fraction where the numerator and denominator is in radical form containing the given index. Now let us have an example. We have here cube root of negative 64 divided by x raised to 6. So this is equal to cube root of negative 4 quantity cube divided by cube root of x squared quantity raised to 3. Now, negative 64 is just equal to negative 4 quantity raised to 3. Why? Because negative 4 quantity raised to 3 is just equal to negative 4 times negative 4 times negative 4. So negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. So we have expressed our negative 64 in such a way that it will have a base and an exponent which is equal to our index, because we will be using here the first law on radicals, diba? Wherein if the index and the exponent are the same, then the answer will be the radicand. Now, we have expressed as well x raised to 6 into x squared raised to 3, because 2 times 3 is just equal to 6. So this is just x raised to 6. Again, we have expressed our expression x raised to 6 in such a way that we will have an exponent which is equal to our index. Now, applying the first law on radicals, we have here your index and your exponent are the same. So our answer here will be the radicand. So we will have negative 4. And again here, our index and our exponent here are just the same, so we will have the radicand. Our radicand here is x squared. So our final answer would be negative 4 divided by x squared. So this will be our final answer unless we can still simplify this. But unfortunately, we cannot simplify this one, so this will be our final answer. So it's negative 4 divided by x squared. Now let's proceed with the second one. Square root of x raised to 24 divided by 9. So again, we will be expressing this expression in such a way that we will have to use our second law on radicals. So again, square root of x raised to 24 divided by 9 is just equal to square root of x raised to 24 divided by square root of 9. Now, we can express this one again in such a way that your radicand here will be equal to our exponent. So we can express x raised to 24 as x raised to 12 quantity raised to 2. so that the exponent and the index will be the same. We can also express 9 in such a way that it will have a base and an exponent which is equal to the index. So your 9 can be expressed as 3 squared or 3 raised to 2. Now, if hindi nyo gusto, you can just simplify this one by getting the final answer. So, x raised to 24, or square root of x raised to 24. So again, if our exponent here is 24, our index here is 2. So, we just have to divide the exponent by the radicand, or by the index rather. So, our exponent here is 24, our radicand or our index is 2, so 24 divided by 2, that is 12. So square root of x raised to 24 is just equal to x raised to 12. Now we will go to square root of 9. Square root of 9 is equal to positive 3. So that is why we have here 3. So our final answer would be x raised to 12 divided by positive 3. Now, take note, we are getting the principal square root of our expression. So that means to say, we are just taking the positive value or the positive answer from our square roots, or from the expressions we are getting the nth root. So we won't be using the negative unless if your index is an odd number. So as long as your index is even, we will be getting only the principal square root of your solution. So, magkon kita nga principal square root. Example, square root of 9. Principal square root of 9 is equal to positive 3. But if you say square root of 9, your square root of 9 can be positive 3. It can also be negative 3. Pero kung magkuhan kita nga principal square root, it's just the positive 3. So, marang ginabol natin dyan. Because you might be confused because there will be a lesson nga the square root, most especially square root of a number will be both the positive and the negative value. So again, in this lesson, we will be using only the principal square root or principal nth root of our expression. Assuming again that n is even and a is greater than 0. The third law on radical states that nth root of a is equal to mnth root of a, which is also equal to nth root of mth root of a. This simply means that when a radical contains two indices, it can be combined into single index by multiplying the two given indices. At the same time, the inner and outer indices of the radicand can be interchanged. Here in this expression, the outer index is m, the inner index is n. If we interchange these two indices such that your n will be your outer index and your m will be the inner index, the answer or these two expressions are just the same. Or we can simply multiply your outer index and your inner index to have a single number to get the root of our radicand. Now, let us take this one as, or let us take these two as examples. 6 root of 4. So 6 root of 4 is equal to cube root of square root of 4, which is also equal to cube root of 2. Now, 6 root of 4. Is it possible to get the 6 root of 4? Of course, it is possible, especially if you will be using calculator. But, can we have the 6 root of 4 as a whole number? Or can we simplify 6 root of 4? Notice, 4 is a perfect square, meaning we can get the square root of 4. If we get the square root of 4, our index is 2. 2 is a factor of 6. So we can factor out our 6. The factors of 6 will be 3 and 2. Why do we have to factor out 6? So that we can get an index of 2. So if we have an index of 2, then we can get the square root of 4. So we express 6 root of 4 as cube root of square root of 4 because it is possible to get the square root of 4. Again, we have expressed our 6 into our factors 3 and 2. Naga may 2, naga may 3. Because si 2, if the index is 2, we can get the square root of our radicand, which is 4. So express our 6 root of 4 into 3 or cube root of square root of 4. And square root of 4 is equal to 2. So that leaves us cube root of 2. So again, we have reduced our expression 6 root of 4 into cube root of 2. Now let us have the second example. Cube root of square root of 27. Now, our expression, our inner expression here is the square root of 27. Now, can we get the square root of 27? Of course, we can get the square root of 27. Now, is 27 a perfect square? Okay, 27 is not a perfect square. It is possible to get the square root of 27, but we cannot get an answer, a square root, which is a whole number. But can we get the cube root of 27? What if we interchange our outer index and inner index? Our outer index here is 3. Our inner index here is 2. Would that be easier if we interchange the two indices? So what if we have square root of cube root of 27? Now we know that 27 has a cube root, which is a whole number. So it will be easier for us to simplify this. Unlike kung di dyan, square root of 27, although we can get the square root of 27, but that is not a whole number. So, mabudlayan kita magbuol sang, or mag-simplify sang expression. But here, if we get first the cube root of 27, and that would be 3, then that will give us a final answer, which is square root of 3. Okay? So, we have interchanged our outer index and our index, or our inner index, so that it will be easier for us to simplify our expression. That is why we have this third law on radicals, which is this one. Now let us assume again that n is even and a is greater than 0. So for the next law on radicals, it states that nth root of ab is equal to nth root of a times nth root of b. This means that when the radicand is factorable, it can be expressed as a product of two radicals of the same index. For examples, we have here square root of 50. Square root of 50. 50 is not a perfect square, so it is not possible to get the square root of 50 and have a whole number as your answer. So we expressed instead 50 as the product of 25 and 2 because we know that 25 is a perfect square. So we have expressed our expression in such a way that one factor is a perfect square and the other is not. So square root of 25 times square root of 2 is just square root of 50. So square root of 25 is equal to 5. So it is possible to get the square root of 25 and have a whole number as your answer. Now, square root of 2. 2 is not a perfect square. So we leave 2 inside the radical symbol. Having, and for that, we have our final answer as 5 square root of 2. Next one, we have cube root of negative 8 x cubed. So negative 8, is negative 8 a perfect cube? Of course. Is x cubed a perfect cube? Yes, of course. So we don't need to express negative 8 as a product of two expressions and as well as x cubed. We only need to get the cube root of the individual expression. So we need to get the cube root of negative 8 and as well as the cube root of x cubed. So cube root of negative 8 is just equal to negative 2. And cube root of x cubed is just equal to x. So then, our final answer is negative 2x. Now let us have some exercises. So the instruction is to simplify each of the following radical expressions using the law of radicals. So first up, we have cube root of 64. So again, cube root of 64 will be equal to cube root of 4 cubed. So we have expressed 64 in such a way that we will have a base and an exponent which is equal to the index. Because if the index, again, based on our first law on radicals, if the index and exponent are the same, then our final answer would be the radicand. So we have expressed 64 as 4 cubed because 4 cubed is just equal to 4 times 4 times 4, and that is equal to 64. Now, since the index and the exponent are equal, or if they are equal, then our final answer here will be the radicand, which is 4. So our final answer for this expression will be 4. Now, you will ask me, Ma'am, ang exponent na sa sulod ng radicals, di kung kisa, di ba sa sagwa, may parenthesis pa. They mean the same. If we have cube root of 4 cube sa sulod ang aton nga exponent, and we have cube root of 4 quantity raised to 3 sa sagwang aton nga exponent, they just mean the same. Okay? So, cube root of 4 cube is equal to 4, using the first law on radicals. Now let us have the second example or exercise. Square root of 18, a cubed, b raised to 5. Now, square root of 18, we cannot get the square root of 18. Or I mean, we can get the square root of 18. But that would be, that is not a whole number. Because square root of 18, 18 is not a perfect square. So we need to express 18 in such a way that we will have a factors wherein the first factor or one factor would be a perfect square, and of course the other factor will not be a perfect square. So 18 can be expressed as 9 times 2 because you can possibly get the square root of 9 and have a root which is a whole number. So square root of 9 is equal to 3. So we express 18 as the product of 9 and 2. 9 can be expressed as 3 squared. Why do we have to express 9 as 3 squared? Not just 9 how? Okay, because again, we will go back to our first law wherein if the index and the exponent are the same, then the final answer would be the radicand. So that is why we need to express 9 as 3 squared. Also, a cubed can be expressed as a product of a squared and a squared times a is just equal to a raised to 3 because the law and exponent states that if the bases are the same, we add the exponents. So a squared times a, wherein the exponent is 1, so 2 plus 1 is just equal to 3. So a squared times a is just equal to a cubed. So we have expressed our a cubed as the product of a squared and a. So why a squared? Because again, our exponent here would be 2, our index is 2, so later, if we simplify, our final answer would be the radicand. Now, b raised to 5. We have here b raised to 5. So we have expressed b raised to 5 in such a way that we will have an exponent which is equal to 4. Why 4? Because 4 is divisible by 2. Our index here is 2. So we can divide 4 by 2, unlike by 5. Pwede man kita ka-divide, but that will be, that is not a whole number. So in order for us to have a whole number, so we need to express our b raised to 5 as a product of b raised to 4 and of course b. So b raised to 4 and then here of course we have b. Okay, again, so we have square root of 3 squared. 3 squared is equal to 9. We have here square root of 2. So 2 times 9 is just equal to 18. So they are just the same. We have separated this 2 through the use of your second law on radicals, wherein we can simplify we can express our radicand as a product of two factors or two numbers or two expressions. So 3 squared is 9 times 2, that will be 18. A squared times a, that will be a cubed. B raised to 4 times b, that would be raised to 5. So why do we have this expression? Why do we have to express our expression into this one? Because we are going to go back to the first law on radicals. So 3 squared, square root of 3 squared. So your index here is 2, your exponent is 2. So of course, we will have our answer here as the radicand. So we have here 3. A squared, square root of a squared. So our exponent here is 2, our index is 2. So our final answer or our answer here would be a lang. And that is your radicand. B squared or b raised to 4. So 4 and then 2. 4 divided by 2. We need to divide exponent by 2. If they are not equal, then we have to divide our exponent by our index. So b raised to 4. 4 divided by 2, that is 2. So we have here b squared. So this whole expression here, square root of 3 squared times a squared times b squared is equal to 3ab squared. Again, we get 3 by squaring or getting the square root of 3 squared. We get a by getting the square root of a squared. And we get b squared by squaring or by getting the square root of b raised to 4. And then since your 2 does not have a square root, it actually has a square root, but that would be a decimal. So we mean to say a whole number. So square root of 2. And then si a naton, does not also have a square root because a is not a perfect square, 2 is not a perfect square, a is not a perfect square, b is not a perfect square. So we need to leave our 2ab, our expression 2ab, inside our radical symbol. So our final answer here for number 2 would be 3ab squared times square root of 2ab. Now let us proceed with the third one. So, fifth root of 4x cubed, y raised to 6. So, si 4 naton is not a perfect, it does not have a whole number as a fifth root. Si x cubed naton, hindi man, kumbaga hindi ta na perfect square bala, kung sa square root, perfect square. So, di dyan, hindi man ta na perfect fifth power. Okay, si 4, si x cubed. How about si y? Si y naton, we can actually divide this one. So we can express y raised to 6 as a product of your y raised to 5 and y. So may bilin kita dito nga y, it's because si y raised to 6 naton, yun mo naton nga y raised to 5 times y. Si y nagbilin sa fifth root because wala sang fifth root si y. How about si y raised to 5? Fifth root of y raised to 5 is y. That is why we have here your variable y outside our radical symbol. Okay, number 4. Fifth root of square root of 32. Now, can we get the square root of 32? Of course. But, is the square root of 32 a whole number? Or can we express 32 into a simplified form? Okay, square root of 32. 32 is not a perfect square. So, of course, we cannot get a square root of 32, which is a whole number. Now, how about the fifth root? Now, if we try to interchange our indices here, our index here is 5, here 2. So, if we cannot get the square root of 32, then we will proceed with the fifth root of 32. Now, can you get the fifth root of 32? So, what do you think is a number, or what number do you think na kung i-multiply tang 5 na kabilog, ang answer is 32. Actually, the answer there is 2. So, if we multiply 2, 5 balik 2, then we will have 2 times 2 times 2 times 2 times 2. 2 times 2 is equal to 4, times 2 that is 8, times 2 that is 16, times 2 that is 32. So, it is possible for us to get the fifth root of 32. So, we interchange our indices. So, we interchange 5 by 2 and 2. So, our fifth root of square root of 32 now is equal to square root of fifth root of 32. Now, fifth root of 32 is equal to 2. So, our final answer is square root of 2. Now, let us proceed with the fifth example or exercise. Square root of 25x divided by 121. So, again, using our law on radicals, we can express this one in such a way that we will have the individual square root of our numerator and denominator. So we separate. So square root of 25x divided by 121 would be equal to square root of 25x divided by square root of 121. Why do we have to do this? Because we know that there is a square root of 25 and there is also square root of 121. Square root of 25 is equal to 5. That is why 5 here is outside our radical symbol. Now, since our x does not have a square root, so your x, or the x, will remain as the radicand of our radical symbol. And square root of 121 is 11. So our denominator now is 11. Our final answer for this exercise will be 5 square root of x over 11. Now let us have the 6 to 10 exercises. So again, simplify each of the following radical expressions using the law of radicals. So we have number 6. Square root of a raised to 14, b raised to 10. Now, if this is the expression, notice that our index here is equal to 2. We are getting the square root. Our exponents here are even numbers. So, it is possible to get the square root of these expressions. So, if you want to get the square root of these expressions, then you need to get the square root of a raised to 14 and the square root of b raised to 10. Now, 14, or square root of a raised to 14 would be a raised to 14 divided by 2. So you need to divide the exponent by the index. So 14 divided by 2 is 7. So square root of a raised to 14 is a raised to 7. Now, square root of b raised to 10. So again, divide our exponent by the index. 10 divided by 2, that is 5. B raised to 5. So square root of b raised to 10 is equal to b raised to 5. So our final answer then is a raised to 7 times b raised to 5, or a raised to 7 b raised to 5. Number 7. Square root of a raised to 16 divided by 16. So again, we have to separate. We need to get the square root of our numerator and denominator. So square root of a raised to 16, square root of 16. So square root of a raised to 16, again, we divide the exponent by the index. Our index is 2, so 16 divided by 2, that is 8. So we have our numerator as a raised to 8. What is square root of 16? So square root of 16 is equal to 4. So our final answer would be a raised to 8 over 4, or divided by 4. Now let us proceed with number 8. Number 8, square root of 4m squared n squared divided by r raised to 4. Again, we need to get the individual square root of both the numerator and denominator. So square root of 4m squared n squared divided by square root of r raised to 4. So square root of 4 first is 2. Square root of m squared. So we have the same index and exponent. So the answer would be the radicand, which is m, as well as for the n squared, or square root of n squared. So that is n. And then square root of r raised to 4. So 4 divided by our index, which is equal to 2. So that will be equal to 2. So we have r squared. So our final answer then is 2mn over, or divided by, r squared. And then we have the number 9, which is very excited. So we have here cube root of fourth root of 27x raised to 6. Now, is it possible to get the fourth root of 27? Okay, it is possible, but again, it is not a whole number. So we change. So we try to interchange our expression, or our indices. So we try to change 3 and 4. So bayluhon naton. So we will have fourth root of cube root of 27x raised to 6. Now, is it possible to get the cube root of 27? And we will have a whole number as the answer? Of course, it is possible, because cube root of 27 is 3. So, okay, tanang interchange ta. So, cube root of 27 is equal to 3. Cube root of x raised to 6. So, x raised to 6 again, gin-raise natin si 6, or si x gin-raise natin sa 6. So, x, or 6 divided by 3. So, 6 divided by 3 is equal to 2. So that is x squared. So cube root of 27x raised to 6 is 3x squared. Then we have here our fourth root. So our final answer would be fourth root of 3x squared. And then for the last number, we have here cube root of square root of 64. Now, is it possible to get the square root of 64? Is 64 a perfect square? Okay, it is a perfect square. So, it will be easier for us to get the square root of 64. It will be a whole number. So, square root of 64 is equal to 8. Okay, so, our expression will be cube root of 8 na lang. Because again, square root of 64 is equal to 8. So, is it possible to get the cube root of 8 and have a whole number as the answer? Of course, cube root of 8 is equal to 2. Because if you multiply tatlo ka 2, then we will have 2 times 2 times 2. So 2 times 2 is equal to 4 times 2, that is equal to 8. So therefore, cube root of 8 is equal to 2. So our final answer here for number 10 is 2. Now let us proceed with simplifying radical expressions. So in this lesson, you learners will be simplifying radical expressions using the laws of radicals. So it will just be the same as our exercises just a while ago. In simplifying radical expressions, we can remove perfect n powers. So we break down the radicand into perfect and non-perfect n powers and apply the property n root of ab is equal to n root of a times n root of b. So let us have an example. So we have here square root of 8x cubed y raised to 6 z raised to 13. Now, notice that this whole expression is not a perfect square, but this expression has factors which are perfect and non-perfect squares, because we are using here your index is equal to 2, so we are dealing with square roots, so we will be dealing with perfect squares and non-perfect squares. Now, we will be expressing this expression in such a way that we will have factors which are, again, perfect squares and non-perfect squares. So for 8 is not a perfect square. So we need to express 8 in such a way that our two factors will have, or the two factors, the one factor will be a perfect square and the other factor will be a non-perfect square. And that will be 2 and 4. 4 is the perfect square and 2 is not the non-perfect square. So we will have 4 here, and we have expressed 4 as 2 squared. 2 squared because we will be using our first law on radicals. So ang index natin will be the same sa exponent. So we can get the final answer as the radicand. And we have here the non-perfect square, which is 2. We also have x cubed. So, what are the factors of x cubed? Ang isa is perfect square, ang isa is non-perfect square. So, we have x squared and x raised to 1. So, we put our x squared here and our x here sa other side. So, this radical symbol or this square root symbol will have the perfect squares, and this radical symbol here or our square root here will have the non-perfect squares. So again, x cubed will be x squared times x. So we put the x squared here, we put the x here. Y raised to 6. So since our exponent here is even and our index here is 2, so we can divide 6 by 2. That means to say y raised to 6 is a perfect square. So we just put y raised to 6 here. Now, we express y raised to 6 as y raised to 3, quantity raised to 2, because 3 times 2 is just equal to 6. We do this so that we can have our y raised to 3 as our answer, because our index and our exponent will be the same. Z raised to 13 can be expressed as z raised to 12 times z. So z raised to 12 is a perfect square, z is not. So si z di dyan, si z raised to 12 di dyan. We express z raised to 12 as z raised to 6, quantity raised to 2. Because again, this will become the radicand, this is the exponent, our index here is 2. So our final answer here later, if we get the square root, will be the radicand. Now, again, these are our perfect squares. Data na non-perfect squares. We will be simplifying already. So, square root of 2 squared. So, again, the answer here will be the radicand because the exponent and the index are just the same. So, we have 2. Here, we will have x because, again, our index here is 2 and our exponent here is 2. So, we will have x. Y raised to 3, quantity raised to 2. Our exponent is 2, our index is 2, so we will have the radicand as y raised to 3 as our final answer. Z raised to 6, quantity raised to 2. So again, we will have index and exponent which are the same, so our final answer will be the radicand, z raised to 6. Then we copy the non-perfect squares. So hindi natin mapagawa si 2xz sa square symbol because they are non-perfect squares. So our final answer then will be 2xy raised to 3, z raised to 6 times square root of 2xz. So that is how you remove perfect and powers. So this will depend on the index. Kung index mo is 3, then you will have perfect cube. Diba? If you have 4 as your index, you will have a perfect fourth power. If you have 5 as the index, you will have the perfect fifth power. For this, we will be reducing the index to the lowest possible order. So we express the radical into an expression with a rational exponent, then simplify the exponent or apply the property mth root of nth root of a is equal to mnth root of a equal to nth root of mth root of a. Now let us have an example. So we have here, what is the 20th root of 32 m raised to 15 n raised to 5? We will be expressing our index. We will be getting the factors of our index. So factors of 20 wherein it would be possible to get the nth root of our expression. So 32. So between the factors of 20, we have 1 and 20, 2 and 10, 4 and 5. Diba? So between the factors of 20, which do you think is the most appropriate new index for our expression 32, m raised to 15, n raised to 5? Now we are already familiar with 32. 32 has fifth root. Remember that. 5 is also a factor of 20. So it could be possible, or it would be possible for us to express our index as a product of 4 and 5. So we will be getting the fifth root. Now, let's have m raised to 15. Would it be possible to get the fifth root of m raised to 15? Of course, because our exponent here is divisible by 5, which is the index. How about n raised to 5? Okay, it would also be possible to get the fifth root of n raised to 5 because our exponent here is divisible or can be divided by our index, which is 5. So now, we express 20th root of 32 m raised to 15 n raised to 5 as fourth root of fifth root of 2 raised to 5 m quantity or m cube quantity raised to 5 and raised to 5. Now, so we express 20 as a product of 4 and 5. So we have two indices here, 4 and 5. We make 5 as our inner index so that we can get the fifth root of our expression. Now, we express 32 as an expression wherein the base, it has a base and an exponent which is equal to the index. So 2 raised to 5. So 32 is just equal to 2 raised to 5. We have expressed as well m raised to 15 into an expression wherein it has a base and an exponent which is equal to the index. So m raised to cube, or m cube rather, or m raised to 3 quantity raised to 5. So your 5 here and the index here are just the same. So the final answer, or the answer here later, would be the radicand m raised to 3. And then n raised to 5. So 5 is just equal to 5. So this expression is now equal to fourth root of fifth root of 2 raised to 5 m cube quantity raised to 5 and raised to 5. We will be simplifying now. So we copy the fourth root, we simplify the inner root or the inner expression. So fifth root of 2 raised to 5 again. So the index and the exponent are the same, so the answer would be the radicand, which is 2. Now, m cube is the radicand. So the index and the exponent are the same. So final answer, or answer here, would be the index, which is, or the index, or the radicand rather, which is m raised to 3. And then n raised to 5. So the same lang, 5, 5. So the answer would be our radicand. So our final answer then for this expression would be fourth root of 2m cube n. Okay? Simplifying radical expressions, we can also rationalize the denominator of the radicand. Rationalization is the process of removing the radical sign in the denominator. So examples, we have cube root of 3 divided by 4k. So we apply the law on radicals. So we will have actually cube root of 3 divided by cube root of 4k, or we can simply proceed to our rationalization. So rationalization means we need to multiply our numerator and denominator by a certain expression so that our denominator will be a perfect truth. So in this case, because our index is 3, it should be a perfect cube. So 4k is not a perfect cube. So we need to multiply an expression to 4k so that your 4k will become a perfect cube. So ano i-multiply natin kay 4 para maging perfect cube? Okay, so we need to multiply actually 4 by 2. Because 4 times 2 is equal to 8. 8 is a perfect cube because cube root of 8 is equal to 2. So we need to multiply 4 by 2. So that is why we have here 2. Okay? Now, we are getting actually a certain expression to multiply our numerator and denominator so that our denominator will be a perfect nth power. So it will be a perfect cube in this case because we have here our index as 3. What will you multiply to k to be a perfect cube? So k, so we need to multiply it by k squared because k times k squared is equal to k cubed. K cubed will be a perfect cube or is a perfect cube. So our denominator here, which is 4k, will be multiplied or will be a perfect cube if we multiply it by 2k squared. Okay, so we need to multiply the whole expression, the numerator and the denominator, by 2k squared. Why do we have to multiply both the numerator and denominator by this same expression? Naga nga kailangan natin multiply by 2k squared si numerator kasi denominator. Because if you are going to multiply the numerator by 2k squared and the denominator by 2k squared, this is just equal to 1. Diba? The numerator is just the same as the denominator. So if we divide this 2, that will be equal to 1. So it's just like multiplying our expression by 1. But in this case, if i-multiply ro naton, we will have a denominator which is a perfect cube. Ang aton nga goal dyan is to remove the radical symbol from our denominator because we can only simplify or we can only say that a radical expression is in simplified form if the denominator does not have a radical symbol. So in this case, our denominator has a radical symbol because if we express this one using our law on radicals, this can be cube root of 3 divided by cube root of 4k. So there is still a radical symbol. So we need to rationalize. So we have to multiply our expression, our numerator and denominator by an expression so that our denominator will be a perfect cube. And those expressions will be 2k squared. So we multiply the numerator by 2k squared, we multiply the denominator by 2k squared. Whatever expression you will multiply the denominator, see to it that it will be multiplied as well sa aton nga numerator. Now, 3 times 2k squared. So 3 times 2, that will be 6k squared. So we have here cube root of 6k squared. Next one, 2k squared times 2 squared, k. Where did we get 2 squared? Again, we express 4 as an expression with a base and an exponent. So, nagiging pakita yun natin. It's because we have multiplied our numerator and denominator with an expression wherein the numerical coefficient is 2. So, gin-express lang si 4 as base 2. So, 2 times 2 squared. So, it's just like 4 times 2. So, it will be equal to 8, which is also equal to 2 cubed. K times k squared. So, we copy the common base k and then we add exponents. So we have here 1 plus 2, that is 3. So that is k cubed. So our expression now is cube root of 6k squared divided by 2 cube k cubed. Again, 2 cube here is equal to 8. We have expressed lang 8 as 2 cubed because we want to show that our index here and our exponent are the same. So we simplify. So cube root of 6k squared. So we know that 6 is not a perfect cube. K squared is not a perfect cube. So we leave them the same lang. So no need to simplify our numerator. How about here? Cube root of 2 cubed. So the index and the exponent are the same. So we will have the radicand 2. K cube or cube root of k cube. So the index and exponent are the same, so we will have the radicand k as our answer. So our final answer then will be cube root of 6k squared over or divided by 2k. So let us have a summary. So the simplified form of a radical expression would require, first, no prime factor of a radicand that has an exponent equal to or greater than the index. Second, no radicand contains a fraction. Third, no denominator contains a radical sign. That is why we have to rationalize. So this is how you know that your radical expression is in simplified form. Now we will have our exercises. So we simplify the given radical expressions. First, we have square root of 10 divided by 25. So square root of 10 divided by 25 is square root of 10 divided by square root of 25. Square root of 10, 10 is not a perfect square, so we leave square root of 10 as square root of 10. Square root of 25 is equal to 5, so our final answer here would be square root of 10 divided by 5. Next, fourth root of 16 y raised to 8. So fourth root of 16. So what is fourth root of 16? So is it possible to get the fourth root of 16 and have a whole number as the answer? So fourth root of 16 is equal to 2 because 2 raised to 4 is equal to 16. So 2 times 2 times 2 times 2. 2 times 2 is 4 times 2 that is 8 times 2 that is 16. So fourth root of 16 is equal to 2. Next, fourth root of y raised to 8. So again, if if the exponent is divisible by the index, then you can just divide. So 8 divided by 4 is equal to 2. So fourth root of y raised to 8 is just y squared or y raised to 2. So our final answer then would be 2y squared. Number 3. Cube root of 3xy cubed over or divided by cube root of 27. So cube root of 3xy cube, the only perfect cube here is the y cube. So we can get the cube root of y cube, which is equal to y. So that is why y is outside the radical symbol. 3 is not a perfect cube, x is not a perfect cube, so we leave 3x inside the radical symbol. So for the numerator, we have y, cube root of 3x. Cube root of 27. Cube root of 27 is equal to 3 because 3 times 3 times 3 is equal to 27. So our final answer then would be y, cube root of 3x divided by 3. Number 4, 6th root of 27m cubed and raised to 9. So, is it possible to get the cube root of, or 6th root of 27 and have a whole number as the answer? Okay, not. Okay, because 27 is not a perfect 6th power. So instead, we will have factors of 6. So we will have to separate our, or we will have to express 6 as a product of two indices. So 6 is a product of 3 and 2. And we can get the cube root of 27. So we can have the square root of cube root of 27 m cubed and raised to 9. Again, we have expressed 6 as the product of 2 and 3. So our index here is 2, our index here is 3. So 2 times 3 is just equal to 6. So that is square root of cube root of 27 m cubed and raised to 9. So why do we have to do this? Because again, 27 is a perfect cube. M cubed is also a perfect cube. And raised to 9 is also a perfect cube. So it will be perfect to get the cube root of this expression. So we copy the square root symbol. Cube root of 27 is 3. Cube root of m cubed is m. And cube root of 9, n raised to 9 rather, is n raised to 3. Now, can we still get the nth root of one expression here? Okay, it is still possible to get the nth root of, or the square root of our n raised to 3 because our exponent here is still bigger than the index. So you will know that it is already a simplified expression if the exponent of our expressions here, or our variables, is less than our index. Okay, but since our exponent here for the n is still greater than our index, so we can still simplify this one. So n cubed can be expressed as n squared times n. N will be, or will remain inside the square root symbol, but the n squared will have its square root. So square root of n squared is equal to n. That is why we have here n outside our radical symbol. So our final answer then would be n times 3mn, or square root of 3mn. N square root of 3mn as our final answer. And then, fifth, we have here fifth root of 32 divided by x cubed y squared z raised to 14. So again, we separate the square root symbol or the fifth root symbol. So we have fifth root of the numerator and the fifth root of the denominator. So fifth root of 32 divided by fifth root of x cubed y squared z raised to 4. So that will be equal to fifth root of 32 is 2. Now, is x cubed y squared z raised to 4 perfect fifth power? Okay, they are not perfect fifth power. So meaning we cannot get the fifth power of x cubed y squared and z raised to 4. So is this simplified? Is this radical expression already simplified in simplified form? Of course not, because we still have a radical symbol in the denominator. So again, we will know that this is a simplified radical expression if there is no radical symbol in the denominator. Now, we will have to rationalize. So, we need to think of an expression na kung i-multiply natin sa aton yung numerator and denominator, our denominator will become or the expression inside the radical symbols sa aton yung denominator will become a perfect fifth power. So, what will you multiply to x raised to 3 to become a perfect fifth power? So, this is 3. So, para maging fifth power dyan, you need to multiply this one to an expression wherein the exponent will be equal to 2. And the base, of course, will be equal to x. So that is x squared. Why x squared? X cubed times x squared is equal to x raised to 5. Because the rule says you need to add the exponents kung the same ang base. So x cubed times x squared is equal to x raised to 5. So the exponent now is the same as the base, or the index rather. So we can simplify it. So x raised to 5 is already a perfect fifth power. So we need to multiply x cubed to x squared. How about y squared? So 2 ja, 5 ja, so we need 3. So we need to multiply y squared to y cubed. Z raised to 4, we need 1 more. Diba? So we need to add 1 pa sa aton niya exponent. So that is, we multiply z raised to 4 by z, or z raised to 1, because 4 plus 1 is equal to 5. So again, we will be multiplying our expression by fifth root of x squared y cubed z, y x cubed y x squared y cubed z. Again, si x squared, kung i-multiply mo kay x cubed, that will be x raised to 5. Si y cubed, kung multiply natin kay y squared, that will be y raised to 5. Si z, kung i-multiply natin kay z raised to 4, that will be z raised to 5. And the expression will now be a perfect fifth root. So we can easily get our, or perfect fifth power. So we can easily get the fifth root of our expression. So we need to multiply 2 divided by fifth root of x cubed y squared z raised to 4 to fifth root of x squared y cubed z divided by fifth root of x squared y cubed z. So whatever you multiply to the denominator will be multiplied also to our numerator. So 2 times fifth root of x squared y cubed z is equal to 2 fifth root of x squared y cubed z. Divided by, okay, so fifth root, x cubed times x squared, that is x raised to 5. Y squared times y cubed, that is y raised to 5. Z raised to 4 times z, that is z raised to 5. So fifth root of x raised to 5, y raised to 5, z raised to 5. Then we simplify. Numerator natin, we have 2 raised, or 2 fifth root of x squared, y cubed z. And then, fifth root of x raised to 5 is x. Fifth root of y raised to 5 is y. Fifth root of z raised to 5 is z. So we will have x, y, z as our denominator. So our final answer will be 2 fifth root of x squared y cubed z divided by x, y, z. Our denominator now is free from radical symbol. Okay? So that will be simplifying radical expressions. So that is it for this video tutorial. Yay! So the focus of these topics would be loss on radicals and simplifying radical expressions. This will be a prior knowledge to the next video that will be presented by Ma'am Fortuna Familiaran, because she will be discussing operations on radical expressions and as well as solving radical equations and problems involving radical expressions. So you need these topics or you need this lesson first. So I'm so sorry about all the lapses that I have today, or all the shortcomings. So I'll see you on the next video tutorial. Stay safe and healthy always, mga palangga. Bye!